Okay, we'll continue in this video with more implicit differentiation exercises, and we'll look at number 9. And in this exercise we have x cubed minus 3x squared y plus 2x y squared is equal to 12. We start as always taking the derivative of both sides with respect to x. Next we begin the differentiation process. X cubed, the derivative of x cubed, is simply 3x squared. Then minus, now we have the derivative of the product 3x squared y. So I'm going to put this in parentheses because it's a complex expression. And we have the first, I'm going to treat 3x squared as the first function. And so I have the first times the derivative of the second, or 3x squared times y prime. Y prime is the derivative of y with respect to x. So that's the first times the derivative of the second plus the second, which is y, times the derivative of the first, 3x squared, which comes out to be just 6x. And I'll close the parentheses there since that negative sign only applies to the product 3x squared y. Next we have the derivative of positive 2xy squared. Again, it's a product. Here there's no negative sign involved, so it's not as complicated. And the first function, 2x, the derivative of the second function, y squared, will be 2y to the first times y prime, plus the derivative of the second. We did the first times the derivative of the second, then we'll do plus the second times the derivative of the first. So the second function being y squared, and the first function being 2x, and its derivative just being 2. And of course the derivative of 12 of any constant is 0. Alright, so we'll simplify what we have here. 3x squared minus 3x squared y prime, then minus 6xy, then plus 4xy y prime, and finally plus 2y squared. And that's equal to 0. So we have, taking the derivative of both sides with respect to x, we simplified. Now we're going to collect our y prime terms on the left side and move everything else over to the right. So I'll begin with the positive terms to make it easier to work with. And that's 4xy y prime minus 3x squared y prime. I'll move to the other side, the negative terms first, so I'll move 6xy across, and then minus 3x squared and minus 2y squared. On the left side, I factor out the y prime now, leaving y prime times the quantity 4xy minus 3x. And on the right side, I have 6xy minus 3x squared minus 2y squared still. When I divide both sides by 4xy minus 3x, I end up with y prime is equal to 6xy minus 3x squared minus 2y squared divided by 4xy minus 3x. And that does it for this one. With number 11, we begin to work with trigonometric functions. And specifically, we have sine of x plus 2 cosine of 2y is equal to 1. We're going to take the derivative of both sides with respect to x. So, taking the derivative of the left side, the derivative of sine x is just cosine x. The derivative of 2 cosine 2y, we have the chain rule here, along with an implicit differentiation. So we take the derivative of the outside, leave the inside alone. The derivative of 2 cosine of something is negative 2 sine of something. So that's taking the derivative of the outside, leaving the inside alone. Then we're going to multiply that by the derivative of the inside, which is 2y prime. So notice that the multiplying by 2y prime doesn't go inside the parentheses there. It's multiplied times the derivative of the outside, leaving the inside alone. On the right side we get 0, and we'll simplify that up just a bit. And we have cosine x minus 4 sine of 2y times y prime. We're going to isolate the y prime term. So negative 4 sine of 2y times y prime is equal to negative cosine of x. Divide both sides by 4 sine of 2y by negative 4 sine of 2y. So the negatives cancel. We get cosine of x divided by 4 sine of 2y. And that does it for number 11 in this video.